So our next session is Future-Proof Solutions for Sustainable Pouch Packaging, and brings together three panelists to discuss environmental regulations and how the innovative technologies pathway to commercialization fits into the picture. Product testing in the new R.A Jones Pouch Lab, key market indicators for global flexible packaging market, and navigating environmental regulations while still meeting consumer demands. A lot of pieces of the puzzle. That's one of the analogies that I bring in so many different times. But the three different perspectives here on this market, and each one of these sessions at Global Pouch Forum, you'll see, we bring multiple perspectives into the discussion. So I think that really helps. And we're going to kick things off here with Jens Bodo Wagner from Nestle. He's going to introduce the session and our panelists. So let's give everybody on the stage here a nice warm welcome.
So, good evening, ladies and gentlemen. I have the honor of starting the introduction. My name is Jens Bodo Wagner. I am from Germany, Nestle. The brand is Maggi. Not sure if some of you know it, because Maggi is more promising in Europe and Africa and also in Asia. But in the US, we're not so broad spread, but still in my factory we have some export articles like Hunter Schnitzel. We get some German Schnitzel over here to the US as well, so some might be around. Coming back to myself, I'm 20 years with Nestle now. Basically, I'm a maintenance guy, keeping the machines up and running for all the years we have them. And this is like also meaning retrofitting and keeping them up to speed for new materials changes and coding and different other stuff that changes over the years. And so I'm happy to be here, happy to having us here, and we'll switch over to Scott.
Thanks, guys. Good morning, everyone. My name is Scott Matre, and I'm with Watrin. I look after the United States and the Canadian market. Started with Watrin very recently, January 6th. I'm employee number 1 in the United States. I'm very happy to be expanding in the States, but I do have about 20 years packaging experience, a lot in rigid and beverage and food. Turn it over to Ricky.
Hi, thank you. Ricky Lowe. I manage the product and marketing team at R.A Jones. Again, thank you to the team here, especially Jens flying all the way from Germany to share this experience with us. R.A Jones, we design and manufacture, primary and secondary machinery out of our location here in Covington, Kentucky. We are actually celebrating our 120 years this year, something to be proud of. And with projects like this, I think the main key point was to share some important experiences that the three companies had worked together to bring this to life. And I'm going to pass it back to Scott to walk us through some of those points that we're going to share with you today.
Okay, I'll stay in, so we remain seated. I'll go through the 5 points we want to touch upon, and starting off with the challenge. So, what was the challenge? Challenge is, as we already heard, that there are some legislations coming up, and they are going to change what we're allowed or not. And since the European Union is doing a lot of legislations also for other countries, not just Germany, but in whole Europe, everyone has to admit to these legislation, rules and policies. So coming back to Germany, we have in whole Europe, you have to go for recyclability material or sustainability material in the next few years. Up to 2030 you have it. So I think everyone has some sustainability. Please could you raise your hands? Who has heard of sustainability and recyclability? Who's working on this all the time right now? So thanks a lot. I think we are really running on this like from 2019 and trying to come up with all the changes to our machinery, standard, intermediate, HFS machines, but also this is more troublesome with ultra high-speed machinery, and this is leading us to the next topic, technologies. So technologies are also quite different coming to all the manufacturing, and some are easier to maintain than others. And ultra high speed and monomaterial, what we are going after, is a lot more different or needs more focused solutions, I would say, to be more on point with keep up with the material. And if I'm talking about monomaterials, this differs from country to country. Like in France, you can go with 90% monomaterial as sustainability and recyclability, But if you're going back to Germany, we are bound by 95%. I can tell you this 5% really makes a lot of difference and giving us a hard time. And of course, when the technology or the machinery is even bigger, it's pushing you a little bit more. Point 3 will be engineering solutions. So this is when we're coming up back to R.A Jones and seeing what engineering can do for you. Switching over then to the partnership which came up between us and bringing all around to the table, like technology with Watron and also engineering with R.A Jones and of course Nestle as a customer and also a driver of this project. And in the end, we also want to have you a little takeaway and go through Q&A and also giving us our opinion what we could take away from this project. This is what we will be discussing around the next 30 minutes. And after that, we will be for roughly 15 minutes for Q&A. So please raise your questions then. Coming back to point 1, challenges. As I already said, you can see on the timeline, we started like in 2019 in our factory. I'm pretty sure that back in the Nestle offices, they were also working with it before that, but this is when it hit us, and this is just showing when they start, okay, we need to change from materials like laminates and all different stuff to more mono-based materials. And starting, of course, with going for biological degradable materials as well, like paper and stuff. But target is, of course, to be still leading. Nestle is quite a big company, I would say, and we like to lead. And I said, I learned already that leading is maybe part of success. So this is what we want to succeed in our market. And so we step from decreasing plastics or switching off to papers, but still we are limited in some spots regarding food and barrier properties. We need to go for virgin materials in Germany. I don't know what it's like in the US, but in Germany we are stuck with virgin materials with food contact regarding paper or also plastics, of course. So monomaterials are the point of choice. You see, we have a whole lot of different stuff like like paper-based or Smarties, which is also based in Hamburg, Germany. They switched totally to paper because it's okay, because the product can do it. But our stuff is like powdery. We have soups and ready meals, also in cups, but also in pouches. And for this, we were looking for the right solutions. And when we started off with this monomaterial, we had a lot of some like coding, sealing, transporting, and every step of the process needs to be redefined. We worked, and when we came across sealing, I can tell you this was really so easy with all the old stuff. And then looking for a technology to go over to this, I will switch to Scott because when we learned Watron and did the first changeovers at our standard intermediate HFS machines, we came to them and really found a nice technology with them and a good solution for our problems with the monomaterial.
Thanks, Jens. So I'm going to take a little technology break here. I think it's show you how the process works, how the new seal bars work, and I think it'll be important to tie back into what Jens needed in the new product or in the new retrofit. So on the left, you see kind of a normal seal bar, it's a drawing of it, but a few things about that. It's one single heat circuit. There's one heat source. There's one temperature sensor somewhere located in that bar, and there's a distance between those two. And then there's a distance between the heat source and the surface, and the temperature sensor in the surface. So that leads to some variability in temperature control. And the third thing is, I think you can agree with me that if that's solid metal, that's a pretty high thermal mass. That whole thing is hot. It might weigh 1 kilo, 2 kilos, who knows? But it's a high thermal mass. Our digital solution on the right has several heating circuits. Its heat source is very close to the surface, but you can see it's just below that gold colored bar, which is a high heat transfer brass, or it could be other materials. And it has a very low thermal mass. So let's define for just a second what a heating pixel is. Heating pixel, you can see down in the circle. I don't know if you can see those lines in it, those little white lines. Heating pixel in this instance is a pixel approximately 5 millimeters by 20. It is a heat source or a heating element printed on a thin ceramic wafer. It contains both temperature sensor and heating element. We can then arrange these pixels in a row to create a seal bar. Now, we talked in the last slide about low thermal mass. because of the low thermal mass of this sealing bar, we cannot complete a quality seal without adding power. There's just not enough heat latent in the unit to create the seal. So what we see is we have to add power for each sealing cycle. So that gives us reproducible results from stroke to stroke because we have to maintain the temperature. And the pixel-wise control, each individual pixel is its own control loop. They're controlled individually. So it gives us high consistency across the surface too. Now, the heating capacity is also because the heat source is very close to the surface, and each pixel is its own power source. It can heat up very quickly at 10 degrees a second, and cool down with air assist. It can cool down as fast as 8 degrees a second. And I think you'll find from Jens that this was critical to its success.
So what we started off with was this one. So basically, if you see your standard HFSS, you know they are retractable sealing bars, and this one is a rotary one, which we touched on. The pouch came from Jones, and we were running the machine for 50 years with standard sealing bars, and everything went well. But from our early experiences with the R.A HFF15s, we had the knowledge that the monomaterial will start to wrinkle quite instantly if you keep the temperature up and running when the feed stops. And of course, I don't like when the machine stops, but it happens. And if we do that, then it's really hard to get it back to action again. And so what we did, we said, okay, we need to have proof of concept. And we talked to Jones, what can we do for the machine? And they didn't have any off-the-shelf solution. And we needed one, but there was nothing to get by. And we know we need rapid heat up, and we also need rapid cooling. And Jones already had something to rapidly heat up, but the cooling part was missing, and this is what Scott and his team could provide. And then we said, okay, we need to put our skin into the game as well. We need to do a proof of concept, and this is what you see on the bottom below. We'll shortly see also a short video of this. We placed 4 sealing bars in the machine, just powered by a battery pack, as you see on top. And we then could run the machine for a short while to see if this will work. Will we be able to run this with these rigged up materials? And finding the solution in this and say, okay, it works, we can do it like this, it cools down, no wrinkling in this area, everything's fine. We also learned that doing this on the field machine is not an option, because we're doing pouches and we want to sell them. So we couldn't really go for all the stuff and do it on our machine all the time and checking and testing. And so we stepped to Jones and asked him to do a 3-part project with Watron, us, and of course themselves, to bring this to our machine and make it running. So handing over to Ricky.
Thank you, Jens. I think one of the most important points you were saying was how do CPG owners maintain production uptime on their machine while being simultaneously challenged with new materials? And I think that was the challenge that was presented to us as a machine supplier. Like I was saying, for the interest of this topic, as part of the Coresia group, we actually have 2 types of packaging machinery. And familiar to some other machine OEM manufacturers here. This is a sister company, Volpac, based out of Barcelona, and this is what we call a linear intermittent mid-speed form-fill seal machine. The machine that Nestle had is a different type of machine, which is a rotary style machine. I'm gonna play that video again, sorry. And like Jens was saying, to be able to engineer a new technology into a rotary sealing wheel like this was not an easy feat, right? It's not like a normal intermittent machine where you could just replace the seal bars with a Watron seal bar. We needed to engineer a solution to replace the entire sealing wheel, provided power, provided with connections to be able to run it, right? So think, on a rotary solution, think slip rings, think engineering, and think all of that. So that's what we needed to do, and we were presented with that challenge in 2019. And like what Jens was saying, we didn't have an off-the-shelf solution. Funny enough, I think back, I think it was 2020. During the pandemic, let's hope that doesn't happen again. We had this pouch forum virtually, I believe, and part of that virtual pouch forum, there was a offline networking chat thing And that's actually where I met the founder and CEO of Watron, where he introduced the technology to us. And at that point, we were already challenged by Nestle with this need to run sustainable materials. So then, we made the connection with Watron, and we found out as well, Nestle had already been working with Watron on different types of machine and how we were going to approach these types of projects. So I think then we had to make a commitment, right? As a machine manufacturer, we did not have a test machine. R.A Jones, our machines today, we run, dry products like spice mixes, soup mixes, and oatmeal. So we're very used to running that. And if you imagine having a test machine running 2,000 pouches a minute, that's really not something that is efficient to do within a facility. So we didn't have a test machine because we were so used to running traditional materials. We knew products that we were running. We didn't really have to test them for us to apply technology for our customers. So I remember, go to my boss and say, oh, hey, we're challenged with this now, right? We've got all our customers asking us to run sustainable materials and we don't have a test machine. We're gonna have to build this test machine to be able to do this proof of principle. So, with the commitment from Nestle, we had our leaderships come together, talk about this, and, we said we needed to do this, right? And doing a proof of principle, I think, most importantly, was understanding the challenge, which we'll talk about here a little bit, both from the technical and the commercial side. So you can see, even before we built the actual test machine, we had to engineer some solutions to understand what we were dealing with. So we had to come up with a similar test stand like this, with a traditional sealing bar, evolve that into what a Watron seal bar would work on a single test stand. And like I was saying, with traditional materials, we knew that on the machine, we were able to seal to give us a quality pouch. But with these sustainable materials, you're now dealing with a different temperature set, different pressures on the machine. So we also now, as a company that builds machine, needed to get involved in the knowledge of understanding film and testing film. So we had to build the infrastructure around that. So that was the situation to get us to as close as possible off-the-shelf solution for Nestle. But the main goal in mind was, how can we help Nestle do this without affecting the production time on their machine, right? So we needed to be able to build this wheel, ship it to Germany, get it in time installed to be able to run the materials that Nestle needed. So I think we're jumping into now, more of what did we learn from this process, right? Obviously, like I was saying, it needed high-level collaboration and engagement between the three companies. We were talking, Jens has been with the machine since it was installed 16 years ago, so he understands the machine back and forth. We started working on this since 2019. So it's been an ongoing long project for us, and we're still working on this on a weekly basis. So it's been good collaboration that's brought us to where we need to be today. They're running successfully today with the films that they want to. And really it was time, money, and resources that we needed to commit to the project so that everybody had skin in the game, right? So it was project management from all sides. And really the goal was very clear to us that we needed to be able to run this material. And we'll talk about that a little bit more after we touch on the technical points.
Yeah, definitely we had to really clearly identify all the root causes. And of course, as I said, one was sealing. There are a lot of other stuff which is going around and is still giving us trouble. But when we started this project for the Jones, which is really a powerhouse in our machine, in our factory, basically just saying, always if someone from our stakeholders comes by our factory, they want to see the Jones, because this is really a nice working machine, and it's the pouch making machine we have, and it's not to be able to come up with, if the machine stops, I would say we can just cope with it. It's really, it needs to run. And so our technical risk was, if we couldn't get it running with the monomaterial, our factory suffered. So maybe we would have needed to replace the machine. And since Germany is not the cheapest state to go for with a new machinery, of course we had the risk that someone else might receive 1 or 2 new machines if we couldn't get the jobs running. So this was really high risk for us. And having learned that we need rapid cooling and rapid heating, leading to new set possibilities with these monomaterials, and keeping all the changes will be down the road, but because we start with monomaterial and it's fine for recyclability, but I guess in a few years it will be thinner. And we have to have a technology at hand which can also be adjusted then, not just for the moment, but also later on. And that we had to test all the potential films with Jones was really good that they built their test rig because of course there were more beta materials which we are not using now, but we had also a stage where we tested different films. And coming back to Jones with their test rig was really an opportunity for us because taking off our machine for this wasn't an option as well. So we built trust between all three companies with this, that we had a solution and technologies, but also having a partner for the testing and engineering, and with us driving the change and the project, really everyone committed to these changes.
Yeah, so I'm going to take the teamwork part and stand up here and cheat and look at the screen if nobody minds. I think one of the things that really worked here was there was a high level of project management coordination. So good PM standards were put in place, weekly meetings, duties were assigned, timelines were established, results were reported. I think the real key that made this thing work pretty seamlessly was the Nestle's commitment from the higher level management. One of our founding engineers got involved in the project, was assigned a very high level of commitment, and of course Jones to go build a test machine, a lab machine that didn't exist was a serious commitment, probably 6 figures or more that they put into that to go forward. And again, all parties brought their best to the table. We put our best engineers, they put their best engineers, and that wrapped around the leadership commitment and the good PM practices brought us a successful project.
Okay, coming back to risk. When we prepared this presentation, Ricky asked me to use a little bit of German on you. So we have a saying, wer nicht wagt, der nicht gewinnt. Basically comparable to no risk, no fun, or who doesn't dare won't win. And I honestly don't want to go out and go all for gambling or stuff, but at a certain point when you want to achieve something, you will have to take risks. We had no off-the-shelf solution, so we had to go for a company who was at that point pretty small, Watron, they were not so big, but we said, okay, this is a technology we can use, this is really solving our issues and our problems, and we believe in this technology that it can be the best we have on the market, and also asked Jones to take it in and find a solution for us. So I think what we really learned from this is, if you don't try things, you will never know if they work, because if they're not there, then you have to be the one to step in and test if it's working or not.
Yeah, so again, one of the things we learned technically with the help of Jens in a lot of the films that we tested is just really how much the process window narrows for sealing a mono material films versus layered films. It comes down, from 25 degrees C, in some cases even down 6 to 8. So we must have reliable heat source, and we must have no variability across heat source or variability from cycle to cycle, or overheating or undershooting on stops and restarts. So that was a critical lesson we learned. Of course, we learned the difference between traditional sealing bars and the new technologies. I think you investigated also another technology and found that it heated up very well, but it didn't cool very well. And then Jens told me when we were preparing for this conference, I said, what does it really mean to you? He said, well, really what we do now is we program and target a temperature rather than a temperature range. I thought that was pretty powerful. I wanted to share that. And then rapid temperature change, the heat up and cool down, was a requirement he brought to the table with us. We didn't actually have active cooling when Jens brought us the challenge. We had to develop an air-cooled seal bar to increase the rate of cooling on our seal bar to his requirement. So thanks for that.
You're welcome.
So I guess I'll speak on, again, the teamwork portion of the clear definition of success. Again, I think we talked about a lot of points between the three of us when we were preparing for this presentation. And really for R.A Jones at that point was, instead of clear definition of success, was clear definition of failure. right? As a machine manufacturer, I think we were in a situation, and Jens even shared this casually amongst our conversations, that if R.A Jones had not taken this step or did not take the risk to invest in this, the biggest risk was Nestle would have considered taking out the R.A Jones line out of their production, right? In their environment, I believe all machines at this Nestle facility today runs a certain type of sustainable or recyclable material. And if our high-speed machine running, at that speed, producing that many pouches is not able to do that, that's going to be a serious risk for us as R.A Jones. So I had to present that to obviously our leadership team to say how critical this was. And obviously Nestle is not the only customer we have in the space, right? At that point, I believe 2019, 2020, all our customers running pouches at this volume were coming to us asking for this solution. So for us, really, it was clear definition of failure from R.A Jones if we did not achieve this. And then, once we got past the investment, it was more, what is the clear definition of success, right? I think, some of you are familiar when you engage in a sustainable project like this, when you talk about materials, right? There's going to be a range of materials out there that you're going to be able to test and run, and there'll be different benefits to each one of them, right? And even that process, from what I've learned from Nestle, for a CPG to go out and say, I can do this material, you're talking about potentially years of testing, right? Understanding how you manage your supply chain for new materials coming in. You're talking about disaster trials, right? Making sure that with this material, I have the barrier properties and the quality of pouches that I have, if not better than what I had before. So this was a long process for us, and we all, between the three of us, needed this clear definition of success to say, okay, we're halfway through this project now. Nestle knows that they've selected this material. This is the absolute success criteria that we were targeting for. We needed to run this material on this machine. And at that point, for us, coming again from the machine manufacturer perspective, is there cannot be any loss of productivity on the machine, right? So we were talking earlier, testing of materials, taking the machine out of downtime was one thing, but if you run sustainable materials, you cannot be producing less than what you're producing today, right? We had to come back and say Nestle needed these amount of pouches the same way it was, or even better than what they were running before. So it wasn't, and I don't think we had an alternative to come back to Nestle and say, oh, could we run at a lesser speed or a lower quality pouch? There was not a discussion of that, right? It was, we needed to run at this speed, we needed to run this material. And the team was clear on that. And then really, I think, along the presentation, you saw a good foundation of partnership, right? Like I said, I met Watron at the offline chat of this forum while it was COVID, right? He had presented his technology. It became clear to me at that point that this was technology, like Jens was saying, that we could use to solve this challenge, and then we jumped into it, right? From then on, it was years of discussions, proof of principle, engineering, and then actually getting the wheel into the system, right? Nestle did a lot of work. I remember being in the factory myself. We had an organized workshop where all the parties came to play. It was 2 days. Everybody had to, put all items on the table, right? What are we going to deal with? How are we going to solve them? And that's what we did. So the machine's running great today. And that drove focus, right? Project management as well. We had each dedicated project managers on our team that helped drive the schedule that needed. Like I was saying, Nestle had a clear roadmap to when they were going to take out the existing material and then go to market with the new material. So the schedule is very important. And I think the last point that we talked about that we wanted to impart with this presentation is obviously with challenges like this that may seem sometimes impossible to do, right? If you look at running a machine like ours with sustainable material, something that maybe Jens was going to touch on too was microstops, right? On our pouch machine, really you don't want it to stop at all, right? Once you stop the machine, right, the film that stays on the sealing wheel heats up, and then you have all these other issues that goes through downstream, right? Now your pouches are of a different width size, you go into the cartoner, you have to manage the integration with the cartoner. So things like that we had to talk about that seemed like a big challenge at that time. But the key message is, if we work together, we can get past the challenge, right? Really, this is not something you have to do by yourself, right? You don't have to do it alone. You can work with the partners here in the room. I'm sure that you already are. Some of you, I'm sure, are already involved in projects like this with multiple partners in the industry. like we have, and I think that's the main thing. If we work together, we can get past these challenges. So thank you. That's the end of our presentation, and we're now open for questions if you have any. Thank you.
So we do have the microphones for anybody who has questions for our panelists. I could get started with one myself. We talk about the need for improvements in all these processes as we transition to sustainable materials. Can you clarify the makeup of the material here? Was it polypropylene, polyethylene? What was eventually decided on, and do both fit in?
So basically, we decided on an orientated polypropylene, so OPP material, which we're using as a mold material.
Okay. And when you look at the cost of different inputs, that definitely factors into things. The sealing technology here, is there a higher level of cost associated with the different sealing approach here?
Yeah, there is. There's no doubt a computerized steel bar will be much more than hunk of metal with a hole drilled in it. There's a high-speed industrial computer that needs to go in the PC in order to do the control and data gathering. And then there was custom engineering we had to do in this application, developing the active cooling. Those costs are coming down as volume comes up, but it's not a percentage more than if you took an old steel bar out that cost you $2,000. It's not a percentage more, it's an order of magnitude more right now. But there's a lot more benefits. But costs are coming down.
Question from the audience here.
Yes, hi. James Fear from Cohesive Digital Printing Solutions. I'm curious as to why your substrate partner was not part of the team. What was the decision-making process by which the partners were selected as part of the development project?
So you mean the film supplier?
The film suppliers.
Yes. To be honest, I was invited by Jones and Wagner to come by and tell the story of the project and knowing this from the engineering part. So as I said, I'm also from technical department. Of course, my colleagues in factory, also engineers for material were involved pretty much as well. Also R&D centers, and also hard. Even with the workshop, we had some guys running around from our main suppliers. So of course, they were involved in this project as well. But to be honest, the film was decided, and with that, we had to make the suppliers of the machine engineering parts doing it with this film, and bring it from beta to workability was of course part of the project, but yes.
I guess to add to that too is the different selection of films required confidentiality between the different suppliers too, that I'm sure many of you are aware of. I think in the early stages when we had this test machine, which now we're calling the Pouch Lab, where we're inviting suppliers and customers to come in and test with us. At the early stages, we were doing all that for free. We were basically telling our customers and their film suppliers, just send us these materials. We want to test and we want to learn how it affects the machine, right? So for, I think, a period of 3 years, basically Jens was sending his suppliers, the film manufacturers, right, our way, and we were also working with our current customers and the film manufacturers, right, testing a whole portfolio of different types of films, and then also maintaining confidentiality between the different suppliers, right, because we didn't want to share, your film is this film is that, this is what you need to do. So we had to learn it ourselves and then report back on what was the best solution on the machine.
Yeah. A lot of questions often center on, well, am I going to need to get a new machine with the new sustainable film? And imagine that was a question addressed here. You talk a little bit more about retrofitting onto existing machinery here and capabilities for that.
Yeah, interesting, because especially with this Nestle project, right? The machine was about 15 years old, so imagine the look at the face of my boss when I told him that, oh, we needed to build this sealing wheel, ship it to Germany, send our guys there, take the other sealing wheel out and put it in and see if it works, right? So that was the challenge. But R.A Jones, like I was saying, we're very proud. We've been around 120 years. We have machines out there that's been, today I think the most active machine is 60 over years. So a big part of our business is actually retrofitting and modernizing our equipment. So that's a capability that we're proud of. And for this project, you think, we were able to do that and prove to Nestle that even though we didn't have an off-the-shelf solution, we could do that. So now we're proud to say we do have the capability with our other customers. If they want to retrofit the machines with this technology, we can do that. Obviously, we're advised to test the materials first in our pouch lab so we know what we're dealing with, and then engineer the right solution for the customer. But as of today, we are actively selling this retrofit to all our customers.
I love that one of the relationships that started here happened during a COVID virtual Global Pouch Forum meeting. I mean, you think about the networking opportunities that can take place in person, but even in a challenged era like that, the seeds of a new business relationship were built. So it's really interesting to see. Let's give a nice hand to our three panelists here.
Thank you.